there is a triangle. Obviously, this is an equitriangle A, B, and C. Each of the side is 3 meter. It means this side is 3 meter, this is 3 meter, and obviously this is also 3 meter. Very first question asked, determine the electric field at the midpoint of AB. It means this is A and this is B. So this is the charge A and obviously B. Charge A is, let's use a different color pen to highlight. So this is 20 and this is minus 40 coulomb. So this is the midpoint. So this is the midpoint. At this point, a point P we have considered. So what will be the electric field at this point, at the midpoint? Obviously, there will be a 2 electric field with respect to P. So we have to calculate the value of E net. So first of all, with respect to P, charge A, electric field will be EA or E1, whatever. So EA, and obviously with respect to P, for minus 40 coulomb, it will be E2. So P point, actually a point charge. Point charge mean a positive one charge. So this is positive as well. It means these two are repel each other. And at point A, the charge is 20 coulomb, and here at P point, the charge is 1 coulomb. In that case, 20 is larger. It means 20 coulomb will repel in this direction. So A will be in this direction. And B point, the charge is minus 40 coulomb, and at P is plus 1 coulomb. It means they are attracted each other. And obviously, minus 40 is larger compared to plus 1 positive charge or test charge or point charge, which is attracted by the minus 40 coulomb at point B. In that case, this point charge will be in this direction. It means the electric field EB will be in this direction. So total E net will be, as they are in the same direction, so that will be added. It means EA plus EB. This is the very basic things, right? So now we have to calculate the value of EA. EA equals to constant 1 by 4 pi epsilon naught. Obviously, all the charges are within vacuum place. It means 1 by 4 pi epsilon naught, and the charge is 20 coulomb. So it will be 20 over, as the distance, let's use a different color pen here. Okay, so the total distance is 3 meter, right? So total distance is 3 meter from here up to B. So half means 1.5 meter. So in that case, here will be 1.5 whole square. So if we calculate, the value will be 8.0 into 10 to the power then unit will be Newton per Coulomb. Now, what will be EB? EB will be same as 1 by 4 pi epsilon naught. Charge will be minus 40. We know that for electric field, the charge positive, negative doesn't matter. And obviously the distance will be 1.5 whole square. So what will be the value? Value will be 1.6 into 10 to the power 11 Newton per Coulomb. By the way, here for AB, direction will be, I'll write down here, direction towards AB. And obviously for EB, direction towards AB. So E total at midpoint of AB, E equals to EA plus EB. So EA is 8 into 10 to the power 10 plus 1.6 into 10 to the power 11. So the value will be 2.4 into 10 to the power 11 Newton per Coulomb. So the midpoint of AB, the total electric field will be 2.4 into 10 to the power 11 Newton per Coulomb. Now, number 2, if Q2 is positive 40 Coulomb, it means before it was minus 40, now it is positive 40 Coulomb. At P point, it means midpoint of AB, what will be the total electric field, right? Here only one change, rest of the things are same as before. Just the B point charge is changed to positive and magnitude is same as before. So EA will be EA as this is 20 and obviously P is a point charge, value is 1, positive 1 Coulomb. It means this 20 Coulomb charge will be repelled towards this direction because this is smaller, that's why. And at P point, positive charge 1 and this is positive 40, it means they also repel each other. It means this will go in this direction, It means they are opposite each other, right? So at P point, the net electric field is equals to EB minus EA. Why EB is here? Because at B point positive 40 and at A point positive 20, it means at B point the electric field is EB, which is larger than this EA. That's why EB is here. So this will be EB. Okay. So we know for both of the electric field 1 over 4 pi epsilon naught is common for each other, and obviously here for B 40 over 1.5 whole square minus 21 over 1.5 whole square. So this will be, this will be actually E net. It means total electric field. So it will be E net or E total. So E net will be, after calculating the value, 8.0 into 10 to the power 10 Newton per Coulomb. And obviously the direction will be towards BA, because this EB is larger compared to EA. That's why let's change the color of the pen. So we could choose white. Okay, so the total electric field will be in this direction. So this is B and this is A. Problem number 3. On the connecting line of two charges where electric fields due to both charges be equal. It means in some point, obviously the very first A point charge is 20 Coulomb, and obviously at B point minus 40 Coulomb. Obviously this is positive. At some point, we don't know exactly, electric field will be equal. So condition, according to question, the question condition is electric field EA is equals to EB at some point where we don't know yet. Let's find out. As A point charge is positive, B point charge is negative, it means in between these two charges, obviously electric field will be available. It means in between this region, electric field will be available, right? Available. At what point where EA is equals to EB, it means at that point electric field or net electric field will be zero. So definitely in this region there is an electric field either outside of the A or outside of the B. Some point there is electric field is 0. It means EA is equals to EB. Let's consider from A point up to this point, a point P where electric field will be 0. So from A, this is X, and the total distance obviously 3 meter. So EA is equals to the constant K, charge 20 over X square, equals to charge 40 over 3 plus X whole square. Let's solve this problem. So here obviously okay, K cancel, X over 3 plus x whole square equals to 20 over 40. So here we could write down x 3 plus x whole square equals to half, or we could write down x over 3 plus x equals to 1 over root 2, or root 2 plus 3 plus x, pardon, this will be equal here. Okay, so x square root of 2 minus 1 equals to 3, or x equals to 3 over 2 minus 1. So if you calculate the problem, so we'll get 7.24 meter. It means from A, let's use another pen to highlight. From A, in some extent at P point where x equals to 7.24 meter, where electric field will be 0. Number 4, if Q is positive 40 coulomb, so this is 40 at B point and this is obviously 20 coulomb, what point the electric field will be equal? So at certain point, let's say this point. Why this point we have chosen? Because if like charges are placed at a distance, the smaller charge, close to the smaller charge, the electric field will be 0. That's why this P point is very close to the smaller charge, 20 coulomb. So at P point, the electric field of 20 coulomb is EA, and at P point electric field EB. As P point charge is positive, this is positive, so they are repel each other. As P is smaller, that's why electric field will be in this direction. As 40 is larger compared to P point positive 1 coulomb, it means this electric field will be in this direction. It means they are opposite to each other. In that case, obviously total distance is 3 meter. Need to remember. So this is, let's say, x from A. Now EA is EB at P point, right? So let's say EA is equals to constant K, 20 coulomb over x square equals to K. So this distance will be, by the way, this is 40 coulomb over 3 minus x whole square. K cancel. X over 3 minus x whole square equals to 20 over 40. So we could write down x over 3 minus x equals to 1 over root 2, or root 2 x root 2 equals to 3 minus x. So x equals to root 2 plus 1 equals to 3. So you could write down the value of x equals to 1.242 meter. It means from a point up to this distance is x, so x equals to 1.242 meter. Question number 5. Now consider Q2, it means at B point Q2 is equals to 0 coulomb, right? This is the condition actually. Now what we have to determine, the electric field at point C. So this is point C. Here electric field will be what? So as this is a triangle, at B point there is no charges. It means at A point there is a charge is 20 coulomb. So for this 20 coulomb there will be an electric field effect on point C. So EC is equals to constant, and obviously the charge, which charge? Because of this charge and the distance, obviously this is 3 meter, so this 3 square. So the value of k is 9 into 10 to the power 9. This is 20 over 9. So we'll get the value of electric field at point C is 2 times 10 to the power 10 Newton per coulomb. If they asked at point C what will be the electrostatic force, in that case force will be Q E. So we actually don't know this Q, because this Q is this one. Obviously in that case this is a point charge, so this Q will be 1 coulomb, so 1, and obviously the electric field will be 2 times 10 to the power 10 Newton per coulomb, and obviously this is 1 coulomb, so coulomb cancel out, so the force will be 2 into 10 to the power 10 Newton. So for this A point at C point, the electric field will be 2 into 10 to the power 10 Newton per coulomb, and the force obviously same as the electric field, that is 2 into 10 to the power 10 Newton. And if the question asked what will be the potential, what will be the potential, what will be the potential at C point, right? In that case, obviously the definition of potential, V equals to the constant K and obviously the distance is R, and here is the charge. So this is 9 into 10 to the power 9 times charge is 20 coulomb and distance is 3. In that case, we'll find 6 into 10 to the power 9 volt. Question number 6. The previous two charges, it means instead of these two previous charges, two charges placed. So at A point, the charge is positive 100 coulomb, and at B point, the charge is minus 100 coulomb. Determine the magnitude and the direction of the electric field at point number C. So this is the point C. So electric field at C electric field for positive 100 coulomb at A point, right? So at A point, positive 100 coulomb, electric field at C will be E1 equals to 100 coulomb, and obviously the distance 3 as these are the equilateral triangle distances. So obviously this will be 3 whole square, and obviously the constant 4 pi epsilon naught. So if we solve this problem, we'll get 10 to the power 11 Newton per coulomb, and 100 coulomb is larger than the one test charge at point number C, which is 1 coulomb, which is smaller actually compared to 100. In that case, they are repel each other, and obviously this is larger, so the electric field will be go in this direction. So electric field will be in this direction, which is AC. So the direction will be towards AC. Same as at point C, electric field for minus 100 coulomb at B point. So electric field E2 will be, let's write down the constant 4 pi epsilon naught, and obviously the magnitude of the charge 100 inside the mod, and obviously the distance is 3 square. So here will be the same value, 10 to the power 11 Newton per coulomb, and obviously the direction towards, so this is negative 100 and this is positive 1. So negative is larger, I mean negative 100 is larger compared to positive 1, and this is positive and this is negative, so they are attracted to each other, and as 100, I mean minus 100 is larger, so the electric field will be in this direction. So CB towards CB. So at this is C point, so the electric field E2, this one, this is CB, and this one is towards this direction, this is E1 and this is E2, and this is, if we could write down A, so this will be towards AC. Anyways, now the total electric field E, let's say this is E net, equals to square root of E1 plus square, obviously, plus E1 2 and cos alpha. Where is cos alpha? So this will be in between these two electric field angle is alpha. So if we solve this problem, let's use another pen. So if we could write down, pardon, we are using different color pen, this one. So this is the straight line, right? Okay, so this one and this one, the electric field, this is E2 and this is obviously E1. So this is the angle alpha. So what will be the value of alpha? If this whole angle of the straight line is 180, right? So this is 180 and this is equilateral triangle. It means this one is 60, this one is 60 and obviously this one is 60. So total will be 180 of the total angle. So this one, what? This one will be 80, pardon, 60. So the total angle for the straight line is 180 and we have to determine the value of alpha. So alpha is equals to 180 minus 60. So it will be 120. So alpha will be 120 degree. So if we plug in all the value of E1, E2 and obviously the alpha, so we'll get the value 10 to the power 11 Newton per Coulomb. And obviously this is the net electric field. The magnitude is 10 to the power 11 Newton per Coulomb. Now time to find out the value of the direction, right? So tan theta, now theta, let's say the referable vector is E2. So from E2 the net electric field will be this one. So this is theta. So tan theta equals to, which one is reference? Obviously E2. Now the value will be here, sine alpha E1 plus E2 cos alpha. If we solve this problem by plugging all this value E1, E2 and the alpha, so we'll get the value theta equals to 60 degree. So here theta will be 60 degree. Number 7, same as number 6 actually. So here at A point, the charge will be positive 100 Coulomb. And obviously the little change from number 6 is here as well. The point charge will be positive 100 Coulomb. Obviously this is B point and here obviously the point C. So here obviously at point C, what will be the electric field and the direction as well. So at point C, electric field for positive 100 Coulomb at A point. So we could write down E1 equals to 1 by 4 pi epsilon naught, the charge 100, positive 100, divided by the distance is 3 square. We already know the distance, so the value will be obviously 10 to the power 11 Newton per coulomb. Same as at point C, electric field for here as well, positive 100 coulomb at point B, E2 equals to 1 by 4 pi epsilon naught, here as well 100 inside the mod, obviously 3 square, so the value will be, so here will be 10 to the power 11 Newton per coulomb. Now the direction, right? So as this one is positive 100 and this is positive 1, so they are repel each other. It means the electric field will be in this direction. So for first case, direction towards AC. And number 2 case, I mean number B, so this one direction towards, so here at point B charge is positive and here obviously positive, so they are repel each other. It means the electric field will be go in this direction, right? So let's use this color. So this will be go within this direction. Use this one. So this will be go in this direction. So this is BA, obviously vector sign. So if we can see, this is actually the vector. Actually this is, we can clean this one first, then we could have a very clear view. So this is actually the electric field line. Let's drop down a little bit down. So this will be the electric field. So this one is E1 and this is E2 and this is total electric field E net, right? So E1 towards AC and E2 is towards BC. Hope you understand this one. So what is E net? E net is square root of E1 square plus E2 square plus 2 of E1 E2 cos alpha. So in between this two electric field, this is E1 and this is E2, in between this two angle is, say, alpha, right? So we know as this is equilateral triangle, so this is 60, so this will be 60 as well, so alpha is 60. Now plug in this value instead of alpha, this will be 60. E1 and E2, we know the value, this one and this one. Let's plug in this two value instead, E1 and E2, and alpha is 60. So we'll find the total value will be square root of 3 times 10 to the power 11 Newton per coulomb. Now the direction, obviously. So we know the tan theta. Which one we should take the reference point or reference vector? Let's say here as well, E2. So which one is E2? So this is actually the E2. So this is E2, and here sine alpha, and this is E1 plus E2 cos alpha. So if we plug in all the value of E1, E2 and alpha, so we'll get the value will be 30 degree. So from E2, this total net or net electric field is 30 degree. So this is the direction of the net vector is 30.